Welcome to the Math Record. Today I'll be covering the CCML Geometry Contest for 2019-2020 Division A, which is this current year. But as I said before, for Algebra 1, I'm not trying to copyright anyone from CCML. I just want to solve the questions. Okay, so I'll go through every single question 1 through 20, and if you want to find a specific question, I'll put it in I put timestamps in the description. And for a few of these questions, I do have some disagreements with some of the answer keys. So I'll tell you what the answer is in the answer key and what I think it is when I solve it. So if you have any disagreements, put them in the comments below, or maybe just send me an email or something. I don't care. Okay. So if you have any disagreements. Number one, solve the system of equations negative x plus 8y equals 12 and x plus y is equal to 3. So to solve this, just use elimination. So add those two equations together, that makes 9y is equal to 15. So y is equal to divide by 3 from is 15 divided by 3 is 5, 9 divided by 3 is 3. So y is equal to 5 over 3. Plug that back into your equation for x plus y equals 3, and that should get which 3 is 9 over 3, so 9 over 3 minus 5 over 3 is 4 over 3. And that should be your coordinate form. So 4 thirds, 5, 4 thirds, 5 thirds in this, right? You gotta write it in this specific form because they're solving for the equation. Okay. Number 2, in figure 1, AD is equal to CD and triangle ABC is equilateral. Determine the area of the ABCD. Okay, so I'm going to draw this out. Um, just to let you know, I kind of had to make these pictures from scratch because I don't actually have the PDF. So if it looks a little weird, yeah, that's kind of my fault. But I'll just draw this out on this side so then you can see it. Okay, determine the area. Since they said that AD is equal to DC, that means these two angles have to be the same. So 180 minus 20 is 60, divided by 2 is 30. Okay, and we already know this is equilateral triangle because that's what the question 2 gave us. So this is 3 and this is 3. Now to find the area of ABCD, the area of an equilateral triangle is x squared square root 3 divided by 4. So x is the side length. So plug in that into this equation. It's 3 to the power 2 is 9. 9 squared 3 over 4, which is just the area of the equilateral, right? Now we need to get the area of, oops, over 4. Now we need to get the area of this section. So that is actually pretty simple if you kind of think about it, right? We cut this right in half and make it 90 degrees. If this is 30, right, then this has to be 60, which makes sense because we bisected the 120. So that if this is side length 3, that's 3 over 2, right? And if you remember your 30, 60, 90 triangles, right, which is 30, 60, 90, which is right triangle. If this is side length x, this is x over 2, and this one's x squared root 3 over 2, right? So using those identities, that means the side length opposite of the 60 is always square root 3 times the one for the 30, right? So what we could do is, since we have the side length for the 60, we gotta divide by square root 3 to get our 30, which is gonna be our height. So 3 square root 3 over 2 square root 3 multiplied by square root 3 on the top and bottom, right? So then this becomes a 3. So 3 divided by 3, those cancel out. So it's just square root 3 over 2 as our side length for the height. Oops, delete. And square root 3 over 2. Okay, so that means the area of this triangle is 3 over 2 times square root 3 over 2 times 1/2, right, to get this side of the triangle, and then multiply by 2 to get the other side, so those cancel out. So that's 3 square root 3 over 4. At with that one, that's 12 square root 3 over 4, which simplifies to 3 square root 3, which is your answer for number 2. Okay. Number 3, determine the length of a 30 arc on a circle with a radius 9, right? So we have something like this, right? This is 30 degrees, and then this radius is 9, so find this length right here. So that's pretty simple. So what's the circumference? Circumference is 2 pi radius. Our radius is 9, so it's going to be 2 times 9, which is 18, 18 pi. Sorry, my pi looks weird. I kind of like draw an N or something. So 18 pi. So that's our perimeter. So this one is 360 all around. Since this is 30, that means using proportions, we use 30 out of 360. Should get us our entire one. So 360 divided by 30 is 12. So divide by 6, that's 3. And then divide by 6 here is 2. So that's going to be 3 times pi over 2. So 3 pi over 2. Okay, so that's number 3. Number 4. In the points 3, 2, 5, 5, negative 2, 3, and xy forms a parallelogram. Determine all possible coordinates. So usually all geometry, I like to make a picture, right? So 3, 2, so somewhere like right here. It doesn't have to be really that specific. It should just be something relatively decent. So, you could be able to see it. So negative 2, 3. Okay, and then we're gonna have xy, which is gonna be our fourth point. So you kind of think about it, to make a parallelogram, the distance that you have to go from here to here is the same distance that you have to go here to here. Or if this was the ending point, then you're gonna have a distance. If there's a point right here, then you go here to here, and it has to be parallel. So, or if it's gonna be something like here to here, right? This one goes this way, or this one has a point right here that goes this way. So to do this, all you have to do is just kind of draw lines and find intersections. So, how it kind of works is, it looks like this, right? So, oops, that looks bad. Um, Actually, let's use different colors so you'll be able to see better. So, something like this, right? And then you have something like this. And then from there, we could get one point, which is right here, right? This and this has to be the same distance. Or you could get something like you have to move these 2 points. So there's going to be a point here. So that means there must be a point right here, right? Because if we had to move this distance, could be the same as this. Or this distance could be the same as this, right? So there's 2 possible points right there, which is the same case as when we did this one and this one. You could also put a point down here. So let me extend that red line, right? Because this distance could be equal to this distance and they could be parallel. So that's what we do. And then you can finally put the last point, um, oops, the last pair of lines, which is crossing them. So we could cross, remember these are our 3 original points, so we have to cross those. So we could cross uh, these 2, and then if those 2, then you could cross that one, which this line is equal to that line, and we have this line is equal to this line, right? Equals this one, which kind of looks really similar, right? So that kind of looks like a triangle. Well, that which makes sense because there's only 3 possible points of um 3 possible coordinates of S. So that's what we need to do. We need to find 3 possible answers. So which is kind of simple. If you kind of think, if you have the point 5, 5 right here, and then you have point 3, 2, and we have point negative 2, 3. In the contest, you really don't have to take this long. If you kind of know the formula, it's really, really simple to do. Well, it's not really a formula, but it's like a process, right? So, to get from negative 2, 3 to 3, 2, right, you had to add 5 to the x, and then you had to minus 1 from the y, right? So then you're going to do the same thing here. You're going to add 5 to the x and minus 1 from the y, because that's the other coordinate, which is going to be 10. So that gives us this coordinate is 10, 4, right? Plus 5 minus 1. And then right here, which is the same thing, right? To get from 3, 2 to this point is this point to this point, right? So it's going to be parallel and it's going to be the same numbers that scales up. So it's going to be, you're going to have to minus 5 and you get to add 1. So minus 5 from here, that's 0, and add 1, that's 6. Okay, or now you could think this way. So 5, 5 to 3, 2, you minus 2 and you minus 3, right? You minus 2 from the x and you minus 3 from the y. So minus 2 from the x, right? So minus 2 from the x, so that's negative 4. And minus 3 from the y, and that's 0. So those are our 3 possible answers. So negative 4, 0, and 0, 6. Oops, sorry, that's 0. I'll draw it better. That kind of, let me draw that one again too. And then 0, 6, and 10, comma 4, which are all your 3 possible answers. Okay. So if you see something like this where you have to find the fourth coordinate, there are always usually three possible answer, unless there's some domain restrictions. Okay, point M, number 5, point M 415 is reflected over line y equals x and translated 3 units down. Okay, to cover the new coordinate, right? So we have 415, so 4 somewhere and 15 right here. And then you have a 7. So this is that line 7 and this 15. That means the distance between these two is 8. So you reflect it over, sorry about that. My voice is dying. So if we reflect it over that, that means we have to go 8 units away from that 7. So 7 minus the 8 is -1. So that's our y coordinate. And then our x was the original 4, right? And now we have to move 3 units down. So 4 minus 3, that means this is our answer. 4, -4. It's basically just that simple. Okay, usually in geometry, you just like to draw pictures and it should be fine. Refer to figure 2, so it's up here. Determine n. So we're just gonna use, it's just a basic inscribe question, which is basically the total length. So let's use the top line first. So n plus 3 plus n plus 1 plus n minus 1 is 2n plus 2, right? Oops, let's kind of move it a little bit over because we need room. So 2n plus 2, right? So the entire length is multiplied by the section outside. So the section outside is n minus 1. It's equal to the same thing on the other line, which is n minus 1 plus, n minus 2 plus 3, which is n plus 1, and then multiply the section outside, which is 3. So this one is 2n squared minus 2n plus 2n, that cancel each other's out, and then minus 2, and that equals 3n plus 3, right? So 2n squared minus 3n minus 5 is equal to 0. So how do we get the middle term? Well, 5 and 2, if you subtract that, we get 3. Okay, so how do we do that? So 2n, n. So we want the 5 to be away from the 2, so we don't want it to be on this side. So we're going to put it here. And this guy has to be the -5 because this is negative. And this is plus 1. So 2n squared plus 2n minus 5n, so that's minus 3n, and then minus 5, right? Perfect. So n is equal to -1, and n equals 5 over 2. So n cannot be -1 is because if you plug in -1 into like some of those lines, you come out with lengths that are negative. Since lengths cannot be negative, then this is not a possible answer. So the only possible answer is 5 over 2, which makes sense because the length has to be greater than at least 2, and this is like 2.5. Okay, so you can write 5 over 2 or 2.5, but I'm pretty sure you most likely write 5 over 2 because if it's not wrong, then don't change it. Number 7, I believe, that we're doing right now. In figure 3, AD is parallel with BC. Determine the perimeter of AB, CD. Okay, so we have something like this. So I usually like to draw it straight, even though I kind of put this in the document kind of weirdly. So this is 45 and this is 60. So if this is 45, then this 60, that means this is 45, right? And they said that AD, this line and this line are parallel. So if that line is parallel, then this angle also has to be 90 because this is 90. So if that's 9, if this is 90, then this is 45, right? 45 plus 45 is 90. So that's 105 added with the 60, right? That means this last triangle angle is 75. Okay, so we are able to get everything now. So we know this is 3 because it's in the picture that I gave, right? Which is what they give in the contest. Now we just need to find this side length, this side length, and this side length, okay? They're not all the same side length. I just use X, like a treasure map or something. Okay. So, we could use something called the law of sine, which is basically, if we have a side length, divide by sine of that angle, and then the B divided by sine of B, or equals C divided by sine of C. So how it kind of looks is that if this is A, this is B, this is C, and this is angle B, this is angle A, and angle C, right? So it's gonna be whatever the opposite angle is, it has the same letters, right? So that's basically the law of sine, which is pretty basic and easy to remember. Okay, I mean it's not really that basic, but it's relatively basic. Okay. And then, so using that, 3 divided by sine of 60. Sine of 60 is going to be square root 3 over 2, which is something you just need to memorize because the 30, 60, and 90 triangle and the 45, 45, 90, right? And there's also one that you're going to use here, which is the 15, 75. Okay, so dividing by this is 6 divided by square root 3, right? Dividing by a fraction is multiplying reciprocal, and then multiply by square root 3 on the top and bottom. So this becomes 3. So that's going to be 2 square root 3. So that's going to be our constant that we're going to be working with. Okay. So that means to find this length, which is square is 45, right? We have to find x divided by sine of 45. So sine of 45 is square root 2 over 2. So so 2 square root 3 times square root 2 over 2. That's going to cancel out the 2, and that makes square root 6. That means x is equal to square root 6. Okay, so we got that part done. Okay, so x is square root 6. Okay, so we got one of the side length. Okay, now let's get this side length, right? So that side length, because using this side length, we will be able to get these two because they're basically the same. So to get that side length, we had to use the 75 angle now, right? So it's gonna be, let's call that x now. So x divided, actually, I don't like that blob. It's kind of 6, and this is x, right? So x divided by sine of 75. Sine of 75, it's kind of weird because if if you don't know it, then I don't know how you're gonna solve it usually. So 75 and 15. There are ways you could do it, but it's you usually don't like to. So how I would like to do it is imagine you have a right here, right? This is your 45, 45, and this is your 30, right? Because that's gonna make your 75, and then there's a 15, right? And then you're gonna be able to get a 75 because this is gonna be you're gonna know the side length and you're gonna know this one, and you can just use the law of sine to like work to find the other side lengths basically. So it's really annoying, but that's basically kind of how you do it. But if you don't want to do it, then you could just memorize it, which is square root 6 plus square root 2. This is gonna be 4, and this is gonna be square root 6 minus square root 2, right? So how I remember, bigger angle, bigger number. That's what you add. Smaller number, smaller number, so you subtract. Okay, makes sense? And 6 minus 2 is 4, and that's how you remember this one. Okay, so that's how you're just gonna have to memorize it. Usually I do. When teachers say that you don't have to memorize, that's kind of a lie. You kind of at least memorize at least some stuff. So 2 square root 3. X divided by sine of 75. Sine of 75, as I said, square root 6 plus square root 2, or 4. Right? And then you multiply to that side length. So it's just going to be x times square root 6 plus square root 2 over 4. Okay, so that gives us this side length. But let's kind of not simplify this just yet, because to get this side length, you just have to know that the hypotenuse, if it's a 45, 45, 90, you have to divide by square root 2 to get the other side length. So you're going to divide by square root 2. So divide by square root 2, multiply on the bottom, right? So then you divide by square root 2. And then that only gets us one of these, right? You want both of them. So you're going to multiply by 2 on top. Okay, so what can we cancel out? The 2 and the 2 here makes a 4, so cancel out with this one. This one's in parentheses, remember? Right? Okay, so square root 3 times square root 6 here is going to be 3 square root 2. And then square root 3 times the square root 2, let's just write it as like this first, because we're going to be dividing by the square root 2. So square root 2 divided by the square root 2, cancel it out, cancel it out. So this one is just 3 plus square root 3, which is both of these added together already. So 3 plus square root 3, right? Plus the square root 6, plus the 3 here, that gives us 6 plus square root 3 plus square root 6. And that is your answer for number 7. That was long. Okay. Number 8, which refers to figure 4. Okay, so to determine angle B, ABC. Okay, so I'm going to draw this out for you. Okay, so something like this with a quadrilateral. Oops, that's a bad drawing. Like this and this. And then this angle over here, they said it was 2x plus y minus 40. Sorry. Looks terrible. Okay. And they said this angle over here is 4y actually 3y minus x plus a 20. Okay. And then said this one was x plus 10, and they said this one was x plus y. So what you gotta know is that if they share an arc, they have the same angle. So this arc, that means going down, this angle and this angle are exactly the same. And same thing with this arc. If we use this arc, that means this angle and this angle are the same. Okay. So how I know is because just draw the arc out. So if we draw this arc, right, where does it connect? It connects right here and here, right? So draw the line down, connect, right? So this angle, and then draw the line down and connect, right? So this angle and this angle are the same. And you could do the same thing for the other two. So those other two are the same also. So simplifying, so doing just some systems, we have 2x plus y minus 40 is equal to x plus y. And we have 3x minus 3y, sorry. 3y minus x plus 20 is equal to x plus 10, right? So the y here cancels out, so we could be able to find x. So 2x minus x is x, so x is equal to 40 then. Okay, so we already got 40. Okay, now we need to find y. So plugging 40 in, that's 50. 50 minus this 20 is 30. Okay, so 30 plus that 40 again, because this is minus, so going opposite side, you're going to plus that 40. So that's going to be a 70, and then 70 divided by 3 is your y. Okay, so now you have to find angle A, B, C. So you have to find this angle right here. Okay, so that means we have to find this angle, this arc, and then divide by 2, because that's the idea of inscribed angles. So what we could do is that we actually need to find this arc, which is pretty easy, right? Because this angle over here is inscribed to this, and this angle over here is inscribed to here. So now we just plug those numbers in. So add this, that's 50. 40 plus 10 is 50. 50 times 2 is 100, right? Because you're not dividing by 2, you got to reverse it. So that's just the idea of inscribed. Now, now x plus y, so x plus y, which is 120 divided by 3, plus the 90, 190 divided by 3. Now you multiply by 2, which is 380 divided by 3, is this arc. Now, adding them together, that's 300 over 3, 600 over 80, right? Because 100 plus 380 over 3, that's just adding by having the same denominator. So, and the entire thing is 360, right? So 360 minus this angle, right? And multiply by 3 to get the same denominator, so this becomes 1080. So 1080 minus that is 400 over 3, right? So that gives us this. So now we need to divide by 2 because that's our inscribed right here, right? How do I know? Because if you draw the arc, connect those 2 points, and then go down, right? That's your angle right there. So you have to divide by 2. And that, because that's just the idea of inscribed, if you know inscribed angles, which you have to learn for geometry. So that's 200 over 3. Okay, so there's just a lot of formulas you need to know for geometry. If you don't know it, you're gonna be struggling. So you should know. Inscribed are one of the main usage of them, and if you don't know it, then it's gonna be really difficult to solve a bunch of these questions. Number 9, the point 2, 0 is reflected across the line y is equal to square root 3 over 3x and across y equals x. Okay, so let's and then find the coordinates at the reflection. Okay, so first let's just take this step by step. So square root 3 over 3 and then the y equals x, right? So square root 3 over 3. So let's draw that line first. This might look like y equals x, but square root 3 over 3. And then we have a point that is 2, 0, so 2, 0. So somewhere right here. Okay, so if we had to reflect this across right here, what you're gonna have to notice is that if you kind of draw like starting from this point and you go straight up, it's gotta be perpendicular, right? So what's this distance? This distance 2. And this is a slope, right? Because this is a triangle, so it has to follow that formula, which is square root 3 over 3, right? Which is what we gave in the question. So if the slope is square root 3 over 3, and this is 2 already, right? It's gonna be, and this is x, so x over 2. That means x is equal to 2 square root 3 over 3, right? So just some quick maths, right? So you're trying to maintain the slope. So if you're reflecting this point across this line, I don't know if it's gonna be in the y thing. I'm just gonna draw it like this. So it could be in the y, I just don't know. So when you're reflecting this across, it's gotta be a perpendicular line, right? So what we're going to have to do is that we're going to have to find that distance, and then we're going to have to move like kind of like a perpendicular. So we have to move something up here and then move it again, right? So what we could do is that we could look at this number first. So we have a point going up, and we could find that point. At that point, we would just find that intersection, which is 3 divided by square root 3. Opposite and reciprocal gives us the perpendicular line, right? So times square root 3 over 3. So that's got to become 3, and then this square root 3 on top, right? So this cancel each other out, so negative square root 3, right? I'm not going to keep doing the radicals because I'm just trying to solve this to show what the approach is. So y equals negative square root 3. And that has to go through the point 2, 0. So it's got to be x. So negative 2 square root 3. So you have to add 2 square root 3. So the y becomes 0. Right? So that's got to be the equation of this line. Okay. So negative square root 3 over x square root 3x plus 2 square root 3 is equal to our line, which is square root 3 over 3x. So adding this to this guy, that's 4 square root 3 over 3x. So that means to get to 2 square root 3, we're going to have to multiply by 3. That means our x is equal to 3 over 2, right? So if x is 3 over 2, right, we'll plug it into one of our equations to get into, or y. So let's plug into this one because it's easier. So the 3 and the 3 cancels out, so it's just square root 3 over 2. Okay, so that is our coordinate. Okay, so remember this point was 2 comma 0. So if we had to go this way and then go up, and then we had to go back that way and then go up, what would that point be? Well, when we had to get from this point to this point, we had to minus a half and then increase the y by square root 3 over 2. So we got to have minus 1 half from this point, so that's going to be 1, right? 3 over 2 minus, so this is like 1.5 minus 0.5 is 1. So square root 3 over 2 plus square root 3 over 2 is square root 3. And that is this new point right here. Okay, so remember that because we're going to have to work with that. Okay, so we're at 1 square root 3, and that's our point. And now we have y equals x now. And now we have to move that across this line. Okay, so if you want to move this across this line, it's actually really simple. When you're moving anything across ever y equals x, this indirectly tells you just to switch your x and y's. So you just gotta switch your 1 and your 3, which is your, square root 3, so square root 3, 1. And that's your answer. That's your answer for number 9. Another way to think about this logically is that if you don't see that thing, is that you're gonna move this way and then go down, right? Right? Because when you're reflecting on this line becomes this line. So what is that distance from that line? Well, remember, this line is y equals square root, y equals x, right? So this, if our height right here is our y, is square root 3, that means our x is square root 3 at this point. So at this point, we're at square root 3, square root 3. And this is at 1 square root 3, right? So that means our x coordinate is going to be square root 3 because that's going to be our point that we're going to go through. And we went from, okay, right? So so the distance from here is 1 to square root 3. So that's going to be a distance of square root 3 minus 1. And then we're going to move down from this square root 3. So square root 3 minus parentheses minus square root 3 minus 1. So this and this cancel out, and then negative of a negative 1 is positive 1. So that gives you the exact same answer both ways. So that's another way to logically think about it too. And that's for number 9. So your answer is square root 3 comma 1. Okay, number 10. In figure 5, if the square ABCD has area 4 and E is the midpoint of BC, then to determine the length of DF. Okay, so let's draw this out. So they said the area was 4, right? So square root of 4 is 2, so this is side length 2 each way. And then E is the midpoint, right? So that's 1, 1 right here. Okay, so how you kind of think about it is that you kind of extend this line out. I'm just going to use red, so kind of separate it. Okay. So what I drew is a coordinate plane, and let's call that point 0, 0. So at this point, this would be 2 comma 0, right? So you kind of draw this entire thing out as a circle, which makes sense because there's a circle inside. So we're gonna call that circle x squared plus y squared is equal to our radius squared, which is 2, right? So it's 4. Radius squared, right? It's 2 squared, 4. So wow, now what is this line? Well, this line is y. This has a negative slope. Negative what, right? It's changing y over x, so it's 1 over 2. So negative 1 half x. And it has to go through the point 1 comma 0, right? So then you put in plus 1 here, right? Because that's already at the y-intercept. Delete and delete. Okay, so what we could do now is that we could just plug it in the y into here. So we're gonna have x squared plus 1/4 1/4 x squared minus 1 half times 1 is negative 1 half times 2 is negative x, right? And then plus 1 equals 4, right? So that's 5 over 4 x squared minus x, and then put the 4 to the other side, so that's minus 3. And then multiply by 4 because I want to get this into an get this out. So it's got to be 5x squared minus 4x plus 12. I mean, minus 12. Okay, so we know that's true. So let's kind of delete all this because we don't need it. It's fine. You know it's a 12. Accidentally cut a little bit too much. So okay. So we have a 5 here and 5x here. So this could make 2 and 6, right? So that makes 10 and then 6. Okay. So this is gonna be a minus 2 and this is gonna be a plus 6, right? So minus 2 plus 6 minus 4 and then minus 12. So that's perfect. So x equals 2, which is not possible because it's gonna be right here. So this is not our point. Okay, so it's not this point. So x equals negative 6 over 5, which is perfect because our point is like somewhere right here, right? Makes sense. So that's our x coordinate. Okay. And that's why I usually like to draw your pictures because then you can start eliminating possibilities because some of them don't make sense. So we have this as our x. Now what is our y? Well, our y, we just plug it in, right? So plug in our x into here. So that's 3 over 5, right? Plus 1, which is 8 over 5. So our point right here is at 6 over 5, 6, 5 as our x. Sorry. 6 over 5, and this height is 8 over 5. But remember, this height right here is 1, right? So and then you make a perpendicular like line, right? Because this is perpendicular. So 8 minus 5 minus 1 is, so this length right here, just this length, is going to be 3 over 5, right? 8 over 5 minus 1 is 3 over 5. And then this side length is 6 over 5. So we just use the Pythagorean theorem. So that's a 5, sorry. So that's 9. So 3 over 5 squared is 9 over 25. And then 6 over 5 squared is 36 over 25. Adding them together, that's 45 over 25. So and then divide by 5 from both sides. From the top and bottom, that's 9 over 5. So that's going to be 9 squared root 5 over 5, right? As this length. And we know this length, right? This is just another Pythagorean theorem. So that's 2 squared plus 1 squared, which is 1, 4, add is 5. And then take a square root, which is square root 5. So that's the length of this. So then we just need to subtract this length by this length. So square root 5 minus 9 square root 5 over 5. Oops, sorry. It's not 9. This is 3. I forgot to square root the 9. So 3 square root 5 over 5. So that's 2 square root 5 over 5. And that is your answer for number 10. Okay. It's a really long process, but yeah. You could solve a lot of things using coordinate geometry. Number 11, determine the radius of a circle inscribed in a triangle. So that's called in radius, and you just need to know the formula. So it's really simple. It's going to be 2 times the area of your triangle divided by the perimeter of your triangle. Okay, so how do you get the area with 3 side lengths, 13, 14, and 15? And there's another formula that you gotta use. It's called Heroes or Heron's, I don't remember. Heron's area or something. Huron's formula, Huron's area, basically the same. So the point is, you're gonna add these three, which is 13, 14, and 15. So that's 27, 42. 42, and then you gotta divide that number, so that's gonna get 21. Okay, and then write square root, and then write 21 there. And then you can subtract 21 by each of them. So 21 minus the 13 is 8. 21 minus the 14 is 7. 21 minus the 15 is going to be our 6. Okay, so this is 3, 7. This is 2 to the power 3. This is a 7, and this is 2 and 3. Right, so these two threes make 1, 3. This 7 makes 1, 7. And these make 2 to the power 2. So so we're not going to simplify this yet because this is going to be your area. And that's Huron's formula, which is pretty simple to use. Okay, just a bunch of number crunching. So that is our area. So 2 times 3 times 7 squared. I mean, sorry, 7 times 2 squared, right? This is your area right here. And then your perimeter is just what we calculated before, which is 42, right? 13 plus 14 plus 15. So 42 is the same thing as saying 6 times 7, right? And then which is also 2 times 3 times 7. Okay, so 7 here, 3 here, 2 here. So your in radius is 4. Okay, so that's your answer from number 11. Number 12. How many lattice points lie directly inside a circle with radius 5? Center at 3, 3. So you kind of don't care if it's 3, 3 because imagine if it's just a circle, right? If you move the circle anywhere, it's it's just gonna be like moving like the circle to a new place, but the lattice points still stay the same. It doesn't matter. So the 3, 3 doesn't matter at all. So let's just position at 0, 0, and you just kind of have to think about it. Okay, so and this one is radius 5, right? So negative 5 and 5. So 1, 2, 3, 4, 5, center. 1, 2, 3, 4, 5. So when this is 4, remember, it's a 3, 4, 5 triangle, right? So then 3. So this could go up to 3. So 1, 2, 3. So you can't have, the points have to be inside, right? So it's got to be this one, this one. So 1, 2, 3, and then 4 and a 5. So a 4 actually has 5 points that you can work with. Okay, now 3. Remember, this is 3, 4, 5 triangle, so that's a 5. There's a 4 up here, so you have 1, 2, 3, 4, right? So you can't have this one because it's on the triangle. You have to be inside, so this can be 1, 2, 3, 4, 5, 6, 7. So there's 7 of them for the 3. And that's going to be the same logic, right, as for this side, which is 5 and also 7. Because they mirror each other, because this one's a 4 and this one's a 3. I just didn't put the negatives on here. This is actually negative 4 and negative 3. So just know that's true. So that's 4, 3. So I don't know why I deleted that. Sorry. And then negative 2, and then 2, and then 1, and negative 1. That's 0. So negative 2, right? If you put a 4, so how far can this go up? Well, it can't go up to 5 because the radius is 5. So the highest, since this one could go up to 4, this one could definitely go up to 4. And that's the highest it could go, right? It's between 4 and 5, so it has to only go up to 4. So if this could only go up to 4, right? But it could include the 4 because 4 is right here and this one goes up, right? So it can include the 4. That means it has 4 in here, 1 on the axes, and then 4 more down here. So that's a total of 9. And that's the same case for negative 1. Because this one's bigger than a 2, but it's not going to go over the 5 radius. But this is not possible. So this is 9, this is 9. Right? And it's also the same case for the origin, right? Because there's 4 points. So, 0, 1, 0, 2, 0, 3, 0, 4. And then there's 0, 0, and then the negative versions, right? So 0, negative 1, 0, negative 2, 0, negative 3, and 0, negative 4. You couldn't put 0, like 5 and 0, negative 5 because they're on the circle. So this one has 9, definitely. So there's 5 nines, so that's 45. And then there's a 5 here, a 5 here, and two 14s. I mean, two 7s, so that's 14. So that's 10, that's 24, and then 24 plus 45 is 69. So that's your answer. Okay, so this one's just a bunch of like plugging in numbers. So a bunch of number crunching. Number 13, in figure 6, oh, so it's this one. AB is a diameter of circle O. Determine the area of the shaded region. Okay, so let's kind of draw this out again. Bam, bam, diameter. So this was length 2, so this is also length 2, and this is 30. Right, so remember what I said about 30, 60, 90, right? Make a right triangle. So this is 30, this is 60. So opposite of the 30 is half that, so that's 1. Opposite of the 60 is half and then times square root 3. So half of that is 1 times square root 3 is square root 3. Okay, that means the area of this is base times height, right? Our base for, so let's just do this triangle. So that's just going to be square root 3 times 1 divided by 2, right? And then since we want to get the other one, we got to multiply by 2, so let's cancel each other out. So the area of that section is going to just be, of this triangle is just square root 3. Okay, now we need to get the area of this section, right? So what is the angle measure of this? And this is where I said why you need to know inscribed angles, right? Because they're going to use it constantly, even though it's indirectly. So if this is 30, then this arc is going to be 60. That means that tells us this central angle is also 60 degrees. And that's it, and that's basically it. Okay, so the area of a circle, right? This is also radius 2. So it's pi radius squared, right? So 4 pi. And then multiplied by, right, using proportions, that's 60 over 360, which simplifies to 1/6. So multiplying that, that's 2 pi over 3, right? Which is the area that we want. Okay. So now if we want the, and that's the area of this section. So now we just add them both together, right? And that's 2 pi over 3 plus square root 3. And that should be your answer for number, what number was that? Number 13, I believe. Yeah, number 13. Number 14, let A be a coordinate of 0, -1. So let's plot that again. So 0, -1, that's our coordinate A. And be a vertex of equilateral triangle ABC. So it's A is a point on an equilateral triangle. And M is at 2, 0. And it's be the midpoint of BC, which is the other side for the equilateral. So the side length has to look something like this, right? Because if you kind of draw it perpendicular like this, right, we have 2 points and it's equidistant, right? Because it's a midpoint, right? This point is the midpoint, so these two lines are equidistant. Well, if you kind of draw a line, right, this is definitely longer than this. So to to make that possible, we gotta move this line closer so it gets smaller, and move this line further so it gets back. So the shape definitely has to only be like this. Okay, so if vertex B lies on quadrant 1, so this is our B, that means this is our C. Determine the x value of the coordinate. So we need to find this coordinate. Okay, so we have to find the x value. Okay, so let's kind of draw this out. And this coordinate's at 2, 0, and this coordinate is at 0, -1. Okay, so we're gonna do the same thing again, right? So if you kind of think about it, this is equilateral triangle. So if we had to draw out the diagram is bad, but it's actually 90 degrees. If you put the midpoint of an equilateral triangle, right? It's actually always got to be perpendicular. And the reason is because if we bisect it, then these two are the same. Then this is 30, this is 60, and this is 30 and 60. Right? If this is 30 and 60, that means these have to be 90. That means it has to be perpendicular. It's just a property of equilaterals. Right? So that's not really a legit proof, but it kind of works. So if this is 90 degrees, right? And you kind of have to think about it. We have it kind of make a triangle right here, right? So you go from 0 to 2 for your x, so it goes to 2. And then from -1 to 0, you go up 1, right? But this one is so I draw another triangle. So actually, let's stop using white because it kind of looks terrible. It's hard to see. Right, let's use red. So using this triangle, right, which is 90. So this one goes to 1. Now let's use a blue one, which I'm going to draw from here, right? This slope is perpendicular, right? So now you have to switch your x and your y's. So now you can't put the 2 here. You actually have to put the 2 down here, and you have to put the 1 here. Okay? So how do I know how to scale that much by? Well, let's call that 2x, and let's call that x first. So we had to scale it up. So we have to actually just find 2 minus the x, actually. So how do we know this length? Well, it's 0, -1, and 2, 0, right? So then you just use the Pythagorean theorem, which is 1 squared plus 2 squared, which is 5, and then square 5, right? So that's our length. So we know this length is a square root of 5. And remember the property of equilateral triangles. So if this is cut in half, right, this is 60, that means this is the 30 now, and this is the 60. That means this side length is going to be square root 3 times bigger than this side length right here, right? So we have to divide by square root 3. So square root 5, that means it gives us the length for our blue, right? So it's got to be square root 15 uh, I mean square root 5, sorry, divided by square root 3, multi multiplied by square root 3 on the top and bottom, so you rationalize it. So that's square root 15, oops, I don't know how to write. Square root 15 over 3. And that is the length that we have to scale it up to. Remember, the ratio of the legs of the triangle are x and 2x. So multiplying them, doing the Pythagorean theorem, I mean, x squared plus 4x squared is equal to square root 15 over 3, which is same thing squared, which is 15 over 9, right? So cancel that out. That's 5 over 3, simplified. Okay, so that's 5x squared, so divide by 5. That's 1 over 3. That means x equals square root 3 over 3, right? Because that's square root 3 on the bottom, and then you could rationalize, and it's this. So that is our x, right? So we have to move x from 2 away. So your actual answer, right, for our x coordinate is going to be 2 right here, because that's still 2, but you have to move x away, which gives us our coordinate. Okay, so if you don't see this the first time, I kind of understand it. It's one of the actually harder questions. So it's going to be 2, oops, I don't know why I wrote that, 2 minus square root 3 over 3. And it should be equal to, if you kind of simplify it even further, you could just write like this, or you could just write 6 minus square root 3 over 3. And that should be your answer for number 14, right? But in the contest, what they actually wrote for your answer key is 6 minus square root 3 over 2, which I do not believe. Because this point is going to be somewhere like right here, because it's got to be 2 point something, which is not possible, because then they tell us my diagonal is like this, which is not true. So definitely this can't. I don't know how this is gonna be the answer. I think they probably wrote the 2 instead of the 3, but this is definitely the answer, or a possible answer if their answer is correct. But if you have any debates or any corrections to my answer, then you write it in the description. I mean, write it in the comments. Number 15. Segment A, B, and CD are tangent to the circle. If AB is 3 square root 10 and XY is 9 and CD is equal to 6, determine the length of AC. Okay, so we're going to use inscribed again, so let's just worry about one part at a time. So this part only, right? So this is 3 square root 10, and let's call this part A, and this, actually let's call this part X, right? Because A kind of looks like a 9, and this part is 9. So the total length is X plus 9 times the length outside, which is X, is equal to our length squared, which is just 3 square root 10. And that's the total length and the part outside. So it's got to be 3 square root 10 times 3 square root 10, which is just 90. So that's x squared plus 9x minus 90, right? So what part can this work with? Well, it can't be 1 and 90, right? It can't be 2, 45, 3, 3 and 30. Nope. Can't with 4, 5 and 5, which is 1 and 540. 1 and 18. Okay, that doesn't work. I don't know. I can't do math right now. 6 and 15. Okay, that works. So x plus 15 and x minus 6, right? So that makes negative 90. And then the minus 1 is smaller than the 15, so then it makes positive. So x has to equal 6 because x can't equal negative. Okay, so we got that part. So that part is 6. And now we're going to do the same thing for the other one. Oops, wrong one. This part. And we're gonna call this one 9, and now we're gonna call this one x. And this length for CD is 6, so it's gotta be 9 plus x times x outside, right, equals 36. So x squared plus 9x minus 36. So this one's gotta be 12 and 3. So x plus 12 and x minus 3. So this part is gonna be x equals 3, right, because it can't be negative 12. So what they're asking, determine the length AC. So they want the entire length. So we got 6 for this section, 3 for this section, and 9 here. So that's 9, plus that 9 is 18. And that's our answer for number 15. Number 16. Okay, so if so 15 and 60 refer to figure 7. Okay, so remember that. So let's kind of draw this out again. Looks really bad. Okay, so they said BX, so this arc is 172, and DX is 45, so this one's 45, and BAY is this angle is 4x plus 13, so it's gotta be another inscribed angles and lines questions, right? So this recurs a lot. You gotta have to actually learn these. So A, C, and D. So this one's 12. So the inscribed angles and lines questions tells us that if this arc minus this arc, half that equals this one. So that means e equals 45. Let's call this x. So minus x divided by 2 equals 12. So that's 24. And then minus that, that's 21. So x equals 21. Okay, so if this is 21 and this is an entire circle, right? You just add them all up and subtract from 360. So that's 66 plus this part is 23. So that's 66. So 238, right? So this part is 122. So just this section. It doesn't look like it, but it actually is because I can't draw. Okay. So now we're going to do the same thing again. 172 minus 122 divided by 2 is equal to 4x plus 13. So this is 50 minus 2 is 25. 13. So that's got to be 12. 25 minus 13 is 12 equals 4x. That means x equals 3, which is what we're looking for, I believe. Yeah, determine x, which is 3, which is number 16. Number 17, vertices negative 2, 0 and negative 4, 6 of quadrilateral ABCD are dilated with respect to that point. Okay, so we're going to have negative 2, 0, so somewhere right here, and negative 4, 6, so somewhere right here. And it's got to be dilated respect to 0, 1. Okay, so when we're dilating by a factor of 2, that means we're increasing it. So we're going to have new points are like somewhere right here. So let's kind of label these points right first. So that's negative 4 and that's 6. And that is a negative 2 and 0. So if we're doing by respect to 0, 1, right? This goes down 1 on the so it goes to the right. So every single time I'm saying it's moving, it's gonna move from the x and then the y. So it's gonna go 2 and 2 to the left and then 1 down. Okay, so 2 to the left, 1 down. So negative 4 and negative 1, right? Right? Because you're gonna have to dilate by 2, so you just have to increase by same distance. And then from here, you're gonna have to minus 4 and go up 5. So that's gotta be minus 8, 11. Okay, so what's our next point? So because it's a quadrilateral, right? So now we have 6, 4. So 6, 4. So somewhere right here. And then we have somewhere at 3, negative 2. So somewhere right here. Okay, so this is 6, 4, and 3, negative 2. So, and it's dilated also respect to this point, and it's going by a factor of 1/3. So that tells us that we need to go back this way. So when we go from 0 to 6, we're increasing by 6. So since we had to go by a third, we're going to actually go by 2. So then 1 to 4 is goes to 3. So 3 divided by 3 is 1. So plus that 1 is 2, right? So it's go by 1 to 2, right? Because then you can, so it scales by 1 and then goes 2 more. So you can complete the entire thing to 4. Okay. So what's this point? Well, you have to go to the right by 3. So if you go by right by 3 and 1/3 of that is just 1. Now it goes from 1 to negative 2, so you have to minus 3. So it can only minus 1 because you're going by a third. So 1 minus 1 is 0, right? So the actual point is actually like, I'm gonna have to draw this a little bit better. So it's gonna be like somewhere right here. I can't draw the scale, so 3, 2. And this one is at 0, and, oops, sorry. This is at 1, 0. Okay, so now we just had to find the area. So remember, our first points that we didn't change was this, right? That's what those that was our quadrilateral. So what we're gonna use is something called the shoelace theorem, which is pretty simple. So we're gonna start from the first left, which is 6, 4, and then negative 4, 6, and we're gonna go around counterclockwise. Then I drew this a little too big. So 6, 4, and then negative 4, 6, right? That's our coordinate, and then negative 2, 0, and then 3, negative 2, and then we're gonna stop at the point where we started from. Okay, so then we're gonna just do matrix C, so it's like this, like this, like this, and like this, right? So it's just a 2 by 2 matrix. So it's gotta be 6 times 6 is 36, and then negative 16, which is a plus 16, right? Because it's gonna be, that's what matrix is, minus the opposite side. Since it's already minus and negative, that's add. So that's 0 plus a 12, 4 minus a 0, and 12 minus a 12. 12 minus a negative 12 is plus 12, right? So this one's gonna be a 52, that's a 12, that's a 4, and that's a 24. So adding those together, that's 28, and that is 40, and that's 92. And then divide by 2 to get 46. And that's your area of that quadrilateral. Okay. Now we need to get the area of the other one, which is this one, which we change, right? Because to find the ratio of the area of the new to the old. Okay, oops, delete. So the area of the new, we're going to do the same method again. So furthest left is actually the 2, 2. I just can't draw. So 2, 2, negative 8, 11, negative 4, negative 1, and then 1, 0, and then 2, 2. So it's got to be 22 minus negative 16 plus 16, and then 8 plus 44, and then the 0, and then minus 1 plus 1, and then that's 2 minus the 0. So that makes 3, that makes 11, that's 55, and that's 77. 77 plus the 16 is equal to 93, right? So 93 divided by 2 is the area of the new one. Okay. So the ratio of the new area to the old area is just going to be 93 divided by 2 over 92 divided by 2, which you could just cancel out the 2's because dividing by a fraction is multiplying reciprocal, so it just divide, so it just cancels those out. So it just simplifies to 93 over 92. That was a lot of work, and that is your answer for number 17. Number 18. Point A lies on a line K that's parallel to the line determined by that. So if it's parallel, that means the slope are the same. So change the y over change the x. So 6 minus 0 is 6, 8 minus 0 is 8. So that's 3 over 4 x. Okay, if K does not pass through the fourth quadrant, okay, so let's kind of draw this point. So it cannot cross through here. So that means the point has to be like above the origin. So something like this, or like here, here. It just can't be like right here. Okay, that's what it tells us. And through quadrant 4, and the area of ABC is 16. All right, so remember, this goes through 0, that's our B, and goes through 8, 6, and that's our C. Right, so it goes through this one. So our A has to be right here, remember what I talked about. So let's say hypothetically is right here. Right, it's just a general estimate. It doesn't really matter. And then say our A is like somewhere right here, right? So it doesn't really matter where it kind of has to be. It just has to be this certain distance away that makes it the area gonna be 15, right? So what is the distance what is this length right here? What's already given to us is 0, 0, and 8, 6. So the distance is 8 squared plus 6 squared, and then square root that, and that should be the Pythagorean theorem, right? So then that is going to be 10 because 8 squared is 64, 3 6 is 36, 64 plus 36 is 100, square root of that is 10. So this is 10. So the area of a triangle is base times height, right? This is your height divided by 2. So to get area of 15, that means the height has to be equal to 3, right? Because 3 times 10 is 30, divided by 2 is 15, right? So it has to be a constant distance of, so this line has, and this parallel line has to be 3 distance away from each other. So how do we find that? Well, all we had to work with is this. There's actually a general formula how this kind of works. So we know this is our slope. So we know we had to put the 3 in front of the x, right? Because 3 goes with the x. That means 4 goes with the y. So it's a plus 4y or a minus 4y. It's actually going to be a minus 4y on this side, right? Because if we had to equal c and you had to put this to the other side, it's got 3x minus c equals 4y, and then you divide by 4. So 3x over 4, right? So it's going to be a minus 4. And the distance between two parallel lines is to actually have the first, so you have ax plus bx plus, let's say our first y, the first number here is actually, let's say, k, right? And the next one is ax plus by plus c. And these are our two equations, and they both equal to 0. The distance between these two parallel lines, because they have the same a and b, right? X and y are the same. So it's got to be k minus c absolute value, because just in case, depending on which one's bigger. And then take the square root of a squared plus b squared. That's actually the distance between two parallel lines. That's the formula. So we know that this starts at 0, so this c is already at 0. So it's got to be k minus 0 divided by, right? Because our k has to be a constant distance of 3, which is what we got. So our k is 3, and that's 0. And then take the square root of a, sorry, I had to take, I mean, sorry, k is not the distance. Sorry about that. It's got to be k minus 0, because that's equals to our distance, so it equals 3. Square root of a squared plus b squared. So 3 squared plus 4 squared is 25, right? So that's k over 5, which is equal to 3. And then k is equal to 15. So that means our c, right? This is plus k right here. So this one had to plus 15, right? So you have to move this to the other side. That means this is going to be negative 15. Okay, negative 15. And that is your answer. Oh, sorry. And that is your answer for number 18. Okay, actually just make sure a has to be greater than 0. Okay, so 3 is greater than 0, so it works. Because you could actually switch to negative 3x plus 4y. It just depends, because it's the same slope. Because the slope has to stay the same. Right? Okay, in figure 8, so it's this one. If AC is equal to BD, so the reason they said that is that it actually has to be the same. If they're not the same, then it doesn't work. And then MAB is equal to A over 2, and then this. Okay, so we just gotta look at the diagram. So since DGC, right, is A, so it's just that arc, then let's kind of, oops, let's kind of draw that out. And write that one over here. And then draw a circle. And this one's A over 2, this one's A, and this side from here to here is actually 4A. That's what they say. So the angle, the actual angle of this is just this arc plus this arc divided by 2. So it's gotta be A plus A over 2 divided by 2. It's gonna be A plus A over 2 is just 3A over 2, and then divided by 2 is 4. That's the angle of this arc. Okay. Now, if you kind of think about it, let's kind of draw a little bit of things. So this is 3A over 4. Right? Now you kind of like draw a center and you draw these two lines. These lines are tangent, right? So they're 90 degrees. And a quadrilateral, right? This quadrilateral has to add up to 360. If this is 90 and this is 90, that's 180. That means this angle plus this angle, it has to be 180. And we know what this angle is because that's a vertical angle. So that's 3A over 4. That means this angle has to be 180 minus 3A over 4, right? So because 180 minus 3 over 4 plus 3a over 4 is just 180, plus 90 is 360, right? So that gives us um, this angle, right? So this is also the central angle, so it's also equal to this arc, and this one's 4a. So this arc plus this arc is equal to 360. So adding them together, so we have 4a plus this number, so 4a plus 180 minus 3a over 4 is equal to 360. Right? So minus the 180 from both sides, so that makes 180. So that is 16 over 4, so that's 13a over 4 equals 180. So multiply by 4, which is 720 over 13 is a, right? So the question is asking to determine DHC, right? Which is basically just this angle right here, right? So when to find that vertical angle, we just need to plug it in. So it's gonna be 720 divided by 13 times 3 over 4. So this divide 720 divided by 4 is actually 180, right? Because 360 and then times another 2 is 720, right? So it actually multiply. So it's actually 180. 180 times 3 is 540 over 13. And that's the angle. That's your answer for number 19. In their answer, which is the second one I actually disagree with, they put 720 over 13. I think that's because they only solved for A and they forgot to actually solve for the real question, which is actually the angle. But the actual answer should be 540 over 13, which I believe it is, if my math is not incorrect. Okay, number 20, finally. Determine the coordinates of the point equidistance from negative 2, 8, 8, 6, and negative 2, 4. So let's kind of plot this out and think about this graphically, right? There's actually a really simple way to do this. So it's got to be negative 2, 8, 8, 6, all right, and negative 2, negative 4, right? So if you kind of think about it, if you draw a line between this line and then this one, right? A circle to for a point to be equidistant, that means the circle has to go through all this, right? And that's the triangle. But the reason I draw these lines is you technically only need two of them. If you do a perpendicular bisector, and we do another perpendicular bisector, wherever that cross, that should be your center of rotation, which makes sense, right? Because if you do a perpendicular bisector, that means this length equals this length, and then whatever point that you choose here, it has, then this height is equal to the same for both. So that means this length is equal to this length. Now, if you do a perpendicular bisector right here, right, this length equals this length, and then it shares the same height, right? So that means these two lengths are the same. And since this length is equal to this length equals to this length, that means this is going to be your circle. So we just need to do a perpendicular bisector for two of these lines. So let's just do with these points that I already drew. So negative 2, 8. This is negative 2, negative 4. And this is going to be 8, 6. Right? So this doesn't look straight, but it is like straight. I just can't draw right now. So what's the perpendicular bisector of this line? Well, it's just gonna be y equals something, right? So it's gonna be 8 plus 4, which is 4 divided by 2 is 2, right? Because at 2, that's 6 away from here and 6 away from here, right? 2 plus 6 is 8. 2 minus 6 is negative 4, right? So you have the perpendicular bisector. And now we have to do a perpendicular bisector of this line. So what's the midpoint of this? 8 plus 2 is 6. Divided by 2 is 3, right? Because 5 away, 5 away. Then um, 8 plus 4 divided by 2, that's obviously 7, because 8 and 6 between is 7. So that is your midpoint. So this could be 3, 7, like somewhere right here. And then you have to do a perpendicular. So what's the slope of this? 8 minus 6 is 2, and then negative 2 minus 8 is negative 10. So the slope is actually negative 1 over 5. Perpendicular means you have to opposite and reciprocal, so that's actually 5x. 5x, and let's go through a 3, 7, so that's 15, and then minus 8. And it has to go through y equals 2. So our y coordinate is already 2. Plug in 2. So 2 at the 8, that's 10 divided by 5 is 2. So your coordinate for intersection is 2 comma 2. And that's basically it, really fast. Well, out of all these questions, a lot of them are actually with a inscribed angles and lines, so I actually recommend you actually doing those. And if you have any like disagreements with some of my answers, like number 14, which disagree with the actual answer for the contest, and number 19, feel free to put in the description why I might be wrong, or any other ones that I might have done wrong. Well, thanks for watching, and I'll see you at the next math record.